Hello everyone, my name is Anushka Pardesi and currently I am pursuing my computer science engineering at Sri Siddheshwar Women's College of Engineering. Welcome to my YouTube presentation. In this topic, we are going to see an interesting topic that is Geiger Muller counter, also known as GM counter. Now let's see. Geiger Muller counter, invented by Hans Geiger and Walter Muller in 1928. The Geiger Muller counter built upon Geiger's earlier 1908 alpha particles detector. This development marks a significant milestone in radiation physics. GM counter is also used for detecting and measuring radiations like alpha particles, beta particles, gamma particles, and etc. Now let's see the construction of GM counter. It consists of a hollow metal cylinder. This hollow metal cylinder acts as a cathode. A fine tungsten wire is stretched along the axis of the tube. The fine tungsten wire acts as anode. The fine tungsten wire is connected to the positive terminal of a high tension battery through a resistor R, and the negative terminal is connected to the metal cylinder. At one end of the tube, a thin window of mica is arranged to allow the entry of the radiations into the tube. You can see in the figure. Now let's see the working of the GM counter. A high energy charged particle entering through the mica window will cause one or more of the argon atoms to ionize. The electrons and ions of argon thus produced cause other argon atoms to ionize. The result of this one event is sudden, massive electrical discharge that causes a current phase. The current through R produces a voltage pulse of the order of 10 mu volt. An electronic pulse amplifier accepts the small plus voltage and amplifies them to 5 to 50 volt. The amplified output is then amplified to a counter as each incoming particle produces a pulse. The number of incoming particles can be counted. Due to high voltage between anode and cathode, avalanche effects takes place. This is important. An avalanche is a process in which a number of free electrons in medium is subjected to the strong acceleration by an electric field and collide with other atoms in the medium, thereby ionize them. Now let's see the graph of the GM counter. After knowing the graph, these are the some main points, that is date time. It is the time period for which counter is incapable of detecting any further nuclear particle. The date time of the GM counter is 200 to 400. Now plateau. The range of applied voltage over which counting rate remains constant is also called as plateau as shown in the figure. Coaching. When free electrons recombine with positive argon ions, they form neutral argon atoms. This process leads to emission of photons. This results is unwanted pulse. The method of surprising unwanted pulse is generated by a photon. This is called as coaching. Coaching can be achieved by adding ethanol. Ethanol molecules absorb the generated photons and suppress the unwanted pulse. Now, after seeing the construction working graph and diagram, here are some applications, advantages and disadvantages. It is used to detect nuclear radiations and charged particles. It is used to measure cosmic ray intensities. Counter setup is very light weight and portable. It is best for mineral prospecting. Now let's see disadvantages. It has large dead time which limits the counter rate. It cannot detect natural particles, that is neutron. It has low efficiency for detecting gamma radiations. Now, after seeing all the construction, working, applications, disadvantages and advantages, here's the Geiger Molar topic has ended. Thank you for your watching.